Good morning to everyone and welcome to this YouTube channel. Today in this video, I'm going to be solving a particular problem from students which they found challenging in June 2009, question 4 to be precise. Without wasting of your time, I read a question. The question reads, a 25 kilogram plank is suspended horizontally by a rope as shown in figure 2. And this is figure 2 presented on the board. The question A, draw a free body diagram of the plank, and in B, calculate the tension. Alright, so let's get started with the solution. A says, draw a free body diagram of the plank. What is a free body diagram? A free body diagram is a diagram that shows all the forces acting on that object. So, on the body, the plank, we're going to show all the forces that are acting on the plank. So I'm going to represent the plank like this. This is the plank. We are told that the plank is 25 kilograms. So the mass of the plank is 25 kilograms. And since it has a mass, it equally possesses a weight which acts downward from the center. The weight of the plank. Then it is attached by a rope, and this rope is going to possess in it the tension force, which is going to be directed upward. Tension in the rope, and finally there's going to be the reaction force at the wall, because the plank is therefore pushing on the wall, and the wall is going to react. There's going to be a reaction force from the wall, which is going to come out this way at a certain angle called the angle theta. It's going to come out this way. The reaction force at the wall at an angle of the angle of theta. So this is the free body diagram of the system. B says calculate the tension. The tension, la tension. So let's get started. To be able to calculate the tension, we're going to use the free body diagram to calculate the tension, and then we're going to use the principle of moments. The moment of a force is the magnitude of the force times the perpendicular distance from the reference. The perpendicular distance from the pivot. So if I consider my pivot to be at this point, let me call this point A and point B. All right. So if I take moments at point A, it's going to cancel out the effect of the reaction force, which I don't know. So, and I'm going to be able to calculate the value of the tension force. So let's do that rapidly. Taking moments at A, the principle of moment states that the sum of the clockwise moments, or the moments that cause the clockwise rotation, is going to be equal to the sum of the anti-clockwise moments. So take a moment. Moment about A. Take a moment about A. I said already that moment is the magnitude of the force times the perpendicular distance from the pivot. I'm going to label this. Let's say this is the length of the plank, and this is the center. It means that the distance from A to the center will be equal to the distance from the center to the point B. So if this distance is L, this one will equally be L as well. And then this force, the tension force, can be resolved into its vertical component and its horizontal component. This tension will act at an angle of 30 degrees 30 degrees with a horizontal. So I'm going to have the vertical component and the horizontal component of the tension force. And the vertical component is going to be T cos 30. I'm going to have T so here I'm going to have T cos 30, and here I'm going to have T sine 30. I've now resolved the tension force into its vertical component and its horizontal component. So if I resolve the tension force, this tension force into a vertical and a horizontal component, I'm going to have the horizontal component here and the vertical component here. Alright, the vertical component is going to be T sine 30, and here T cos 30. So if I take moment about A, I'm going to have the force T sine 30, which is an anti-clockwise force, times the distance from A. The distance from A is going to be L plus L, which is 2L. 2L. And I believe that's going to be the only anti-clockwise force, because now T sine 30 is T cos 30, which is the horizontal component of the tension force, is also acting at a distance of 2L from A. But now it has no perpendicular distance from A. It does not have any perpendicular because it acts on the same line with A. So it's going to be T cos 30 times 0, because it does not have any perpendicular distance from A. Alright, so this is going to be equal to the clockwise rotation moment, which is caused by the weights acting at a perpendicular distance of L from A. So it's going to be equal to W times L. Alright, from here now, I have that 2LT sine theta sine 30 is equal to WL. And from here, I can simplify by L. Yeah, I can simplify by L. I'm now going to have T, the tension, to be equal to the weight W over 2 sine 30. Numeric. So we have the tension force, which is going to be given by the weight divided by 2 sine 30. But now we know that sine 30 is equal to 0.5, and 2 times 0.5, 2 sine 30 will be equal to 1. 2 times 0.5 is 1. So W divided by 1, weight divided by 1 will be the weight. So in this case, we have that T is equal to W, and W is equal to mg. So it means that the tension in this case is going to be the mass times acceleration due to gravity. Numerical application. Now we're going to have that the tension is equal to the mass. We're told that the mass was 25 kilograms, then times 9.8 meters per second squared. And this is going to give us a tension force of 245 Newton. 245 Newton. So this is where the question ended, but I'm going to add C part of the question, and I'm going to say C, calculate the reaction at the wall. Calculate the reaction at the wall. I'm going to come up in the next video with the solution to calculate the reaction at the wall. But before that, I want you to calculate the reaction at the wall, R, and you can send your solution to me, or you comment your answer in the comment section. See you in the next video. Welcome back, and now we're going to look at part C of the problem, which says calculate the reaction at the wall. Alright, so I believe you have already solved. If you have made an error, you're going to see your mistake when as you watch this video now. Alright, how do we calculate the reaction at the wall? Remember, this system is at equilibrium, and since the system is at equilibrium, it means that the forces that cause clockwise rotation will be equal to the forces that cause anti-clockwise rotation. In fact, like moment, not forces, moment. Clockwise moment will be equal to anti-clockwise moment. Upward forces will be equal to downward forces. Forces moving to the left must also be equal to forces moving to the right. I'll start by resolving the reaction force to its vertical and horizontal component, and how I do it. I'm going to resolve these to a horizontal component and a vertical component. Horizontally, I'm going to have arrow cos theta, and vertically, I'm going to have arrow sine theta. And watch me, r cos theta will be equal to t cos 30. Arrow cos theta is equal to t cos 30. I'll name this equation 1. Then I'll equally have that arrow sine theta will be equal to the weight minus t sine 30. Equation 2. How do I get equation 2? The two forces that are moving upward, r sine theta and t sine 30, will be equal to the weight. So when I manipulate that, I'll have that r sine theta must be equal to the weight minus t sine 30. Alright, so from here, I know that sine 30 is a half. Sine 30 is a half, and then we have the value for t. So this simply means t on 2. This simply means t on 2 is like we are going to have w minus t on 2. But remember, in this case, when we did the second part of the problem, part B, we saw that the tension was equal to the weight. So this w minus t on 2 must give you t on 2 as well. So I am going to say that r sine theta is equal to t on 2. Now watch me divide equation 2 by equation 1, and I'm going to have that r sine theta on r cos theta is equal to t on 2 then divided by t cos 30. And from here I have that tan theta on 2 is equal to a half. Alright, and if tan theta on 2 is equal to 1 on 2, it means that tan theta is equal to 1, because the numerator must be the same if the denominator are the same in an equality. Alright, now if tan theta is equal to 1, then theta is tan inverse of 1, and tan inverse of 1 is pi on 4, or 45 degrees. So it means that our theta is 45 degrees. I'm now going to use this theta and substitute in any of the equation, and I'm going to have the value of r. I choose equation 1. From equation 1, r cos theta is equal to t cos 30. It means that r is equal to t cos 30 over cos theta, and theta is 45. And we know that cos 45 is root 2 on 2. It's root 2 on 2. Alright, when we do that, we're going to have that r is equal to 245 divided by root 2. Yes. Okay. And from here, r is equal to 173 Newton. So the reaction at the wall is 173 Newton. Thank you for watching the video. Subscribe to the channel for more video notification. When you subscribe, whenever I upload a new video, you shall be notified to come and watch. So stay tuned to my channel. If you are writing GC Ordinary or Advanced level,